Hello, Mark Bumpus here. Last week I did a video on riding moment, and this is going to be the second part of that video. This week is going to be extremely exciting because there's some really fast boats. So I didn't get to trimarans last week, so I'm doing the Weta trimaran and the Wave Rider 17 trimaran. And then I'm getting into some of the proas, the one-way proa boats that have won speed records. We're going to look at yellow Pages Endeavour. We're also going to look at a hydrofoiling boat called Hydroptere. And we're going to look at Sailrocket 2, which is the current world speed record holder. But first, I want to go over a couple things. So this is, y'all know what this is. It's a drill. So the purpose of this is to drive, like, let's say you're driving a screw. If you study the forces of this, it's actually not designed in the ideal fashion. You're trying to translate your force through the chuck, but your hand is below the chuck. So if I don't induce some kind of rotation in my wrist, I'm not going to be able to drive the screw properly forward, because what will happen is that's what will happen. If I'm pushing this way and the screw is resisting, you get torque. So it has to do with the offset distance, but these forces are not collinear. My hand is below the chuck. So it's the same thing on a boat. The sail is way up here and the dagger board or the center board is way down here, and it causes the boat to heel. In this video, we're going to talk about how you can eliminate the need for riding moment if you align these two forces so that they go like this. Anyway, this was my industrial design project solution for the drill. The project was to design a better hand tool. I'm sorry, a power tool. And this was my solution. You put your hand here, and now when you push, there's no rotation. See, I can't even make it rotate if I wanted to. But they still haven't figured that out. Okay, so if you haven't already, I highly recommend that you watch the first half of this two-part video on riding moment so that you will get a better understanding. So what I have done is I have taken popular boats and I have drawn them on my CAD system to scale. At least I would say 95% correct. Like, I know the overall width, I know the width of the hulls. I don't really know the dimensions of the outriggers on these, but I've studied pictures and I think they're fairly accurate. Okay, so what we have here is the Wave Rider 17 trimaran, extremely popular with the Everglades Challenge and races like that. And then we have the Weta trimaran. Now, both of these trimarans have, their floats are less than 100% volume, meaning that you can't really, the center hull cannot lift completely out of the water. Let's look at this one first. On this one, you stay inside the cockpit of the hull and you don't shift your weight. The weight of the boat is 145 kilograms. The weight of the person is, I'm just picking 80 for all of these. And so these, the two dots, the person and the boat are basically on top of each other. And then the riding arm, once you start heeling and going faster, you heel about 8 to 10 degrees. And you're sharing buoyancy between the two hulls. In this case, you're slightly more than 50% of the weight is in this hull compared to the main hull. These are the cross-sectional areas of the 98 and the 60. So that's where I get the position for this dot. It's slightly to the outside of the middle, between the centroid of this area and that one. And so you get a distance of 1 meter, 3 foot 2 inches. The sail area on this one is 96 square feet. So you divide the sail area by riding moment and you get 0.42, which is really quite average. Let's look at, okay, the top speed of this boat is about 12 knots. And it's very similar to the Hobie Adventure Island. I think it's the AI, the Hobie AI, yeah. I believe both of these boats can go around 12 knots, but not over 12 knots. All right, now we have the Weta trimaran. The difference between these is you can hike out on these wings, and these wings are pretty big. I saw a guy who got his center of weight almost on top of the outrigger. Now on this one, these outriggers have lower volume than these, but but you have so much more leverage arm from the shifting of the crew weight. So in this case, the boat is lighter. This boat was 145 kilograms. This one's 100 kilograms. This one's 17 foot long, but this one's 14 foot long. But the hull is a little bit more. So this middle hull is a semi-planing main hull, and this one is more of a displacement hull. It doesn't really plane as much. So if we take the weight of the boat and then the weight of the person, and then we find the middle, the average, we get this position for the total weight of the boat, and you take the areas of these two floats. This one is actually a little bit less than this one. So this float carries slightly less than 50% of the weight as compared to this one. So this dot is slightly inside of 50%. So we get 1.4 meters compared to 1 meter. So we have a lower weight and we have a slightly longer distance arm between the two forces, and that gives a higher speed. 20 knots is how fast these boats can go. Sail area, this one is, if you look at this number here, it's quite high. This is one of the higher numbers I've seen. It's not as high as like a windsurfing board, but it's quite high. It's more than the Hobie 16, and it's more than the 49er skiff. So there's a couple of things that could have happened with this design. Is if these floats were larger volume, it could handle a bigger sail and it could probably go faster. The other thing is it could have slightly more of a planing hull in the middle, like this one, and I think that would help it a little bit as well. The problem with having a planing hull in the middle is then what if the wind is like 5 knots? Then your boat might actually go slower. So I've watched videos in this boat. A lot of times at low speeds, you'll notice that the transom is wet, so it creates a little bit of drag. So this boat is basically designed for sailing at higher speeds, and there's always a compromise. So at lower speeds, this boat has a little bit more drag than this one, but this one has a higher top speed. Interesting fact, so this is the wingmaran. This is the boat that I recently designed, and I went ahead and found out what this distance is. It's 1.2. It's 4 foot 1 inches, and that's it's greater than the moment arm of this boat, and it's less than the moment arm of this boat. So I predict a speed of somewhere between 20 knots and 12 knots for the wingmaran. I'm assuming it's going to go about 16, maybe 17 knots. All right, let's get into the high-speed boats that have at some point held records, speed records. This is a very interesting boat. It's basically a one-way proa. If you look at it from the top view, it's basically a Y-shaped structure with 3 rectangular floats. This one is a little bit bigger, and it houses 2 people. So it has 2 people next to each other. So this is the back view of this boat. The wind is blowing that way. This is a hydroplaning surface, and I believe the leeway resistance is with some fins, and I believe the fins are on the windward side. There's a fin here. Now, when this boat gets going really fast, also the hull, all of these hulls look like this, the cross section of the hull. So for low speeds, it has a little step, so it's very much like the float on a seaplane. And then after it gets to a certain speed, the wetted area is from about here to here somewhere, and it has a steeper angle on the front. And the one that houses the people is a little bit, a tiny bit bigger, and it has a canopy, an aerodynamic canopy. And so there's two people here. That's about 160 kilograms. I don't really know the weight of the people that actually beat the record, but I'm just making up a number here. I do know the weight of the boat. It was 177 kilograms. So I can determine the position of the center of mass of the boat plus crew is right here. And I know that the center of lift is going to be on this float because this one lifted like about a foot off the water, if you look at pictures of it. So all of the lift is right here. It's centered on this. Actually, there's two floats. So the center of lift is right here. The center of the sail is here. It's a wing sail, and it's unstayed, and they have these high tension wires underneath the truss system, and that's what keeps the sail from falling over. All right, so the top speed of this boat was 46.5, and the interesting thing to note is the length of this boat is 30 feet and the width of the boat is 30 feet. So it's a perfect square. Another thing to note is the sail, the center of effort is in front of the center of lift, and the center of mass is in front of the CE. So what I don't know is like what these angles are. I just basically estimated these angles. I don't know what these angles are. It could be that this is asymmetric, but it looks pretty symmetric to me just from looking at it. There is not a lot of information on this boat. There's not a single video that I found. Maybe there is a video, but it's not available on YouTube, at least not that I have found. But it is basically a boat that has 3 skimming pads, and the riding moment is 5.7 meters. And also, it has a sail area of 230 square feet. And the ratio of sail area to riding moment is 0.12. So this is very low. And I assume it's because they don't want the thing to flip over, because if you're sitting in here and this thing flips over, that could be extremely dangerous. So I think that's why this number is so conservative. But it does have a very efficient sail. It's a wing sail, and it has 3 hydroplaning skimmers. Okay, so here's the same deal with this. This is called Hydroptere. This is the only boat that I've ever seen in my life that is wider than it is long. This boat is, I believe it's 60 foot long, but it's 78 foot wide. Here's a picture of it. It's a hydrofoil boat, and it's got these, they're angled. They don't really use this anymore, but they used to use this a lot. Actually, they still use angled foils somewhat, but they're usually not attached in this way. So this boat, when I looked up the weight of this boat, I was kind of startled that it's 7,500 kilograms. And okay, so here you have the crew, five people on the wing. You can go up to about, it looks like, see if there's the people, 1, 2, 3, 4, 5, 6, 5 or 6 people. That's only 400 kilograms. The boat is 7,500 kilograms. That means that with all these people over here, it just moves the center of mass like literally about a foot to windward. And then you have lift coming off of both of these foils, but I'm assuming that the lift from this one is about 10 times as big as that, because the boat heels a little bit, and this foil, the angle changes a little bit, and this basically lifts out, so it's almost not doing anything at all. And so I'm just assuming, I'm making an assumption that the center of lift would be somewhere around here, which is it's 10% moved this way, between here and here. And I believe this boat had a T-rudder as well, and that's how it kept its stability. So it has a riding arm of 7.3 meters. The sail area on this boat was 31. I know some people want to see it in square meters, but I just kept everything the same, so this is square feet. Now look at this ratio. This is the weirdest ratio I've ever seen. It's the sail area to riding moment is 0.054, which tells me that the sail could have been bigger on this boat. It probably could have handled more sail. The other thing is, if you scaled this down, then the crew weight would have more effect on this boat. And if you scaled the whole boat down, didn't make it, 60 foot long, and you could probably get better results. Then the ratio of the crew weight would be bigger compared to the boat. This dot would be more over here somewhere as opposed to here. Of all the boats that have a vertical mast, this boat is pretty much the fastest. I don't know of any other boat that has an uncanted mast that's straight up and down that has gone 55.5 knots. That's my take on this boat. Now let's get to the overall winner here. This is the current record holder. And let me get another pencil here. Okay, so with all the other boats, you had the sail going this direction, and you had the fin that's under the water going this direction. And so what happens in this boat is these two forces go like this, and you have no riding moment. The sail force is going this way, and in this case, this boat would fly into the air if it didn't have something holding it down. And so this foil is actually used as an anchor. A lot of people don't realize that. There's everything else about this boat is making it kind of like fly into the air. These are skimmers, so that they're creating hydroplaning lift. This sail is canted, so it has a upward component and a sideways. There's a forward component of the sideways component, and that's what gives you the forward thrust. But there's also a vertical component here. Same thing here. There's a vertical component here. So when it gets going really fast, this skimmer is not even touching the water, and this one is not either. The only one that seems to be, well, these two kind of like skip, barely skipping. And so these skimmers have more dead rise than some of the other boats, because they're just skipping. And actually there is a fin somewhere. I forgot which here there's a fin on the front one, so this is the front one. There's a fin here, and this is, I believe, how they steered the boat, is there was a fin on the front. Now, this is a top view. It's a very strange looking boat. The floats are oriented in the direction of the water, but the hull is oriented in the direction of the apparent wind, which is at an angle of around, I believe it's like around 20 degrees. So the apparent wind is going this way, the boat is going that way, and it's very odd looking boat, but it's the same. It's very similar to the other boats, is that it's a tripod of floats, and if you look at this would be the wetted area under the float. It would look like this, and the aspect ratio of this is only 1. Even the fastest boat in the world uses an aspect ratio that is not ideal. But it doesn't have to be in this case, because the sail is creating all this lift, and so these are basically hopping along. One more interesting thing, this right here is the shape of the underwater foil. So if this tiny little foil here, which is only like 75, I think it's 75 centimeters long, whatever it is, it's a tiny little fin, and it's used as an anchor, but it's in line with the sail. So these two forces go in opposite directions, but they're slightly forward. So all the forward, if you would rotate these forces 90 degrees, you'd have something like this. And then if you take the sum of these forces, so the fin is creating lift this way, and the sail is creating lift that way. And if you take the sum of those, you get forward velocity that way. The thing is, length waterline. I like asking this question. What is the length waterline of this boat? Well, the point is, it doesn't really matter anymore when you're hydroplaning or hydrofoiling. The length of the boat, the shape of the boat, it doesn't really matter anymore, because it's not in the water. Back to this foil. This foil is not a normal foil. This is called a supercavitating foil. So what that means is the entire length from the front to the back, there's only high pressure. There's no low pressure. In other words, there's no shaded area. So like if you were standing here and looking this way, you would see the whole, the oncoming fluid actually sees everything. So there's no shaded area. And so what happens is you get a separation bubble back here, and you get cavitation behind it. There's no cavitation in front of the transom. And so this was needed to reach the speeds, because all the other foils that people were using were cavitating at speeds lower than, what is the speed? Oh yeah, 65.45 knots. That's the speed of this boat. And now, what's going to happen after this? We already know that aligning these two forces works really well. Having a foil in the water to anchor it works well. Now it's just a matter of reconfiguring the structure. Some people have proposed a big kite on a string, and sometimes there's one where the fuselage is literally between the two. It's right here. There's a person in a fuselage, and it's floating. I mean, it's basically flying over the water, and the only thing in the water is this tiny little hook, and the sail is way over here. That's one proposal, and then there's another one which is more like a tripod from the middle. So there's 3 floats All of them are very similar to this float, and then the string is attached here in the middle. The center of mass is in front, is slightly in front of where it's the kite string is attached, but then there's a hook underneath the boat, and so that's the next evolution. And I don't think any boat is gonna beat this speed unless it has this these two forces lined up. I think that is the future, and I think everybody is in agreement with that. But for the other thing I want to point out is this boat is not, you can't really sail this boat in normal. It doesn't tack. In other words, it only goes in one direction with very limited waves. It's not designed for anything but that. Same thing with this boat. It only goes in one direction. The wind has to be going this direction. It's basically asymmetric. So the only boat that is a normal boat that can tack in both directions is Hydroptere. So I think a smaller version of this with a lighter mass and maybe a bigger sail in proportion to its weight would be a really fast boat. And there's not much difference between this and the America's Cup boats. The America's Cup boats look like this, and instead of this big old wing, they have a wing that goes like this. So the boat is not as wide, but it still gets the lift almost to the same spot as Hydroptere got its lift. It's just a little bit in, and these boats go, I believe, 39 knots. They might go faster than 39, but the last time I checked, I think they were going 39 knots, and they could probably go faster if this wing was a little bit further out. But these boats are a whole lot lighter than Hydroptere, and anyway, that's all I have to say.